The glass mirrors that make up the Cherenkov Telescope Array are extremely important for detecting gamma rays. The CTA will be completed in 2024 and there are prototypes being produced right now. The telescopes work through mirrors reflecting flashes of Cherenkov light towards the cameras facing the mirrors. This Cherenkov light has been produced by gamma rays entering the atmosphere and crashing into atmospheric atoms. The cameras can then convert the light flashes into a digital signal. By mapping the Cherenkov light, you can trace back the path of the gamma rays. You can see from the blueprints for the telescopes that the mirror is not made up of one piece of glass. It is instead made up of many smaller mirrors which are hexagonal in shape. But why is this? There are four main reasons. Number one, making one extremely large piece of glass is very difficult. They are difficult to support as once they reach a certain size, they start to sag under their own weight. The glass needs to be perfectly formed in order to reflect the Cherenkov light into the camera. If the mirrors are misshaped, the light won't be reflected into the camera and we won't be able to detect the gamma rays. To stop the big mirror from sagging requires large, heavy and expensive support structures, and it is a lot easier and cheaper to accurately make smaller mirrors that can be fitted together. Number two, the mirrors have to exactly reflect the Cherenkov light into the camera. The camera is supported by large steel beams, but it may still move due to the wind. When the camera moves, the mirrors have to move with it. You would not be able to move a single piece of glass to account for the camera movements, but the smaller mirrors can each be placed on platforms that can move independently. Each mirror position can be altered, allowing each one to always point directly at the camera. This would be impossible to do with one large mirror. Number three, if the telescopes were built with one piece of glass and it was to break, then it would be extremely expensive and time-consuming to replace. This would mean the telescope would spend less time looking for gamma rays. With multiple, inexpensive and light sections of glass, if one were to break, they could be replaced quickly, easily and at low cost. Number four, the telescopes need to move around quickly in order to detect gamma rays coming from a sudden astronomical event. The hexagonal mirrors are lighter than a single mirror, which needs lots of support. This ensures that telescopes can move fast to capture all important gamma ray events. So in conclusion, we have covered the main reasons why we are not going to use one mirror for the CTA. Firstly, they are too heavy, they are expensive to replace, and you cannot move different parts of the mirror. And finally, they make the telescopes too heavy to point in different directions in the sky.